Welcome back to Think Cosmos, where we ponder the universe's deepest secrets and wonders. Shifting our gaze to the cosmic nursery, astronomers have spotted a stellar baby growing at a truly staggering pace. In a star-forming region about 2,300 light-years away, a young protostar is gobbling up material like there's no tomorrow. This star in the making, catalogued as P82, is already huge, roughly 10 to 20 times the mass of our Sun, and it's still just a toddler in star terms. How do we know it's bulking up so fast? Scientists managed to peer through the dense clouds of dust around P82 using radio telescopes, specifically by tracking a telltale molecule, ammonia, swirling in the gas. What they found was essentially a giant disk of gas and dust funneling matter onto the growing star, and the numbers are mind-blowing. QE2 appears to be ingesting about 2 Jupiter masses worth of gas every year. Imagine a star gaining the equivalent of 2 entire Jupiter planets annually. That's one of the fastest growth rates ever observed for a star. At that rate, if it continued steadily, this infant star would double the mass of our Sun in just a few decades. Of course, we don't know if it will keep that pace up for long, but it underscores just how intense and violent the process of forming a massive star can be. Usually, when we think of stars forming, we picture something like our Sun, forming slowly out of a collapsing cloud. But Day 2 shows that when you're dealing with a stellar heavyweight, the feeding frenzy can be extreme. The research team, led by astronomers in Italy, says this supports a long-held idea. Big stars form the same way smaller ones do, by accreting material from a disk, just on a much larger scale. It might sound obvious now, but it wasn't always clear if extremely massive stars could form through a similar disk and gravity process, or if something more exotic was needed. Thanks to these observations, we have strong evidence that nature uses the same basic recipe for stars of all sizes, just scaled up to create the giants. Still, there are mysteries. As they mapped P82's feeding disk, astronomers noticed something lopsided. One side of the disk has roughly twice as much gas as the other, and shows signs of more turbulence. This asymmetry hints that something is channeling extra gas onto that side, possibly a sort of cosmic pipeline feeding the star. They suspect a streamer of gas, like a filamentary tendril extending from the surrounding cloud, is delivering fresh fuel to the disk at a specific spot. Think of it like a gas pump in space, fueling the star from one direction. If true, it's a fascinating glimpse at how the biggest stars in the galaxy might get built, siphoning material along interstellar highways. The team can't see that streamer directly yet. It's kind of like seeing the bathtub filling but not clearly spotting the faucet. However, their data gives them clues of where to look and what to look for next. Future observations with more powerful instruments might catch these cosmic supply lines in the act. All of this leads to an exciting question. How big can this baby star get? Massive stars like P82 don't live very long by stellar standards, maybe a few million years. But in that short life, they can reach hundreds of times the mass of the Sun and shine millions of times brighter. They also have a huge influence on their environment, blasting out intense radiation and eventually exploding as supernovae that scatter heavy elements into space. Right now, P82 is a rare opportunity to watch such a giant in the making. One of the researchers remarked that we need to find out for how long P82 can keep growing. In other words, will it soon run out of gas, literally? Or is there enough in its cosmic nursery to keep feeding this beast until it becomes a true stellar titan? By studying this formative stage, scientists hope to refine our understanding of star formation across the spectrum. It's not just academic. Knowing how massive stars form helps explain the distribution of elements in the universe and the origins of things like black holes and nebulae. And on a more philosophical note, every star, even the biggest, starts out as a baby. Watching one grow by leaps and bounds puts our own sun's humble birth into perspective. It's a reminder that the cosmos builds its brightest, most powerful furnaces from clouds of dust and gas, one gulp at a time.